So today we will go through the silicon life cycle and post silicon validation. So yeah, just we'll go to the contents. So yeah, first thing would be semiconductor product life cycle. So next would be SOC architecture. Then bring up post silicon validation. This is where my expertise lies. So we will go over that in a detailed manner. So yeah, the first thing, semiconductor product life cycle, right? So in the initial phase, you need to know what kind of a product you're gonna launch, right? So for that, you need to understand like which market you are aiming, okay? What would be the cost of that particular product? Then how many interfaces you would need. Interfaces, when you say it could be like PCI or USB 4. Okay, so what would be the power definition of that particular platform? So you decide all of those things in the requirement definition. So in the initial phase, your architect will sit, your customer will sit, all together you create the requirement definition of that particular silicon which you will be building. Okay, and the next thing would be the architecture planning. So in the architecture planning, it is more like how many cores you have for that particular SoC, or how many interface are you planning to have for that SoC. Then what would be your memory architecture, or what would be your clock architecture. So all of those details will come under architecture planning. Okay, and then goes to the designing phase. So all of these phases are like on the pre-silicon side. Okay, and then comes the designing. So in the designing phase, you write all the chip logic. So how your particular chip should behave, that would be written on the designing phase. Consider like your USB 4 should go down when it goes to the low power mode. So you write that in such a way that whenever low power mode comes, then your USB devices should go down. Then if the signal comes up, then you should be able to bring back that IP to the S0 state. So those things would be written in the designing phase. Okay, then comes the verification. So whatever you have written in the designing phase, that you will verify in the verification phase. Okay, and here also you will not have the actual hardware. Okay, you will have the prototype boards to test the whatever you have made during the designing phase. So maybe like you use an emulation or a simulation to test whatever you have designed. Okay, and then goes to the DFT. Okay, in the DFT phase, defect for test. So in this phase, you try to insert a logic where you have like, consider like in the post silicon phase, you may have to debug certain things of your IP or your SoC, right? You may have to read the registers for it. So with the help of this DFT, you will be able to read those particular registers. So you might have heard about JTAG, right? So you may need to use that particular interfaces to access the registers inside the SoC, so that if you find any related bugs, you can debug that. So you are inserting that particular logic in this phase, so that in the post-silicon validation timeframe, you can use that. Then comes the physical design. So the designing, the architecture planning or the designing phase is more like the, what do you say? It's more like a blueprint. In the physical design phase, consider like you're building a house. So in the physical design phase, it is more like you decide where the room goes or how the plumbing should be done. Okay. So in the physical design phase, like you do all the floor planning, what would be the routing, where you should place the particular component. Okay, all of those things would be done in the physical design. It's proper layout of your silicon. Okay, and then comes the tape out. So tape out is like your design freeze, okay, physical design freeze. There won't be any changes happening in that particular tape out in this phase. I mean, after this, okay, so you freeze your particular design. Then we have fabrication. So fabrication is more like you are building your silicon. So manufacturing of your silicon. So once tape out happens, then goes the manufacturing phase. So you build your silicon at this point in time. And next is packaging. Packaging is more like when you have your silicon, so you should be able to place that particular silicon on your motherboard. So if you have to place that silicon on your motherboard, like you will have your interposer, then above that you keep your silicon, above that your heatsink or your fan will come. So packaging is like making that particular silicon, which is built during the manufacturing phase in such a way so that you can place that on your motherboard. So that is what happened in the packaging time frame. And then we have the rest of the 4 are part of the post silicon side, where you try to bring up your silicon, okay, and then you do all the feature validation, functional validation, all kinds of validation. Then comes the production phase, where you try to build your silicon in a mass production phase, okay, and then goes to the customer and eventually to the next generation. So we'll go over the bring up post silicon validation, production, and customer feedback in the coming slides. So before that, yeah, I'll explain a little on the SoC architecture. So you have your SoC. Okay, inside your SoC, in the earlier platforms, we had the North complex and South complex idea. But these days, everything is on the SoC itself. Okay, though you still have the PCH. So inside your SoC, you will have your memory controller, you have your display engine. Okay, you have your PCI. Some of the PCI can also be part of your PCH itself. So your memory controller will be connected to your DDR. Then your SATA will be part of your PCH. Okay, storage controller will be part of your PCH. At the same time, NVMe will be sitting on your SoC, like it is a PCI. It is connected to your PCI. So which means that your PCI will be sitting on your SoC. Then you have display engine. It is part of your graphics and display engine, which is part of your display. Then network, Ethernet MAC controller will be sitting on your SoC. REST, PHY, and everything will be outside. Other connectivity like Wi-Fi, then Bluetooth, all of those again sits on the SoC. Then the sensors, controllers, those things, all of them are part of your PCH. And when it comes to USB, one extensible controller will be part of your, like for example, Type C extensible controller will be part of your SoC, and it will be basically inside your CPU. And another, whenever you connect to USB 2 and all of that, that will go to your PCH. So yeah, this is on the SOC architecture. Then we have, okay, first silicon bring up. So this is the first phase of the post silicon. So in the post silicon phase, you try to turn on your silicon. Basically, first time you're trying to boot your with the new silicon which you got from the factory, you try to boot it with the motherboard. Okay, so now you have a proper hardware, you have your motherboard ready, then you place your silicon in that, and then you try to boot your system with that particular silicon. Okay, so at that point in time, you try to check all the basic boot up, right? So you check the power sequencing, whether first particular signal which should come up, that is coming up. After that, there will be sequence of signals which should come up when you boot the silicon. So whether that is happening, your clocks are behaving fine or not, how the reset of the system is working, okay, reboot, reset in terms of shutdown, all of those things are working fine. JTAG is another. So when you try to access the registers in your silicon, right, whether that you are able to access it with the help of your JTAG or no, whether when you boot the system the BIOS detection is happening or no, BIOS firmware is working or no. Okay, then it is more like the silicon which you received, whether that is properly working or no, whether you're able to boot with that particular silicon or no, with all of these checks. That's what we do in the bring up phase. And we use like oscilloscope analyze. In terms of tools, we might use oscilloscope or protocol analyzers or um, logic analyzers, all of that in this phase to debug if you are finding any kind of issues. Then the next one is post silicon validation. So yeah, in this phase, you basically once the silicon is booting fine, right? You check all the features of that particular platform in this phase. So when you say post silicon validation, it is not only you're qualifying that particular silicon, but you may have to check the entire ecosystem whether it is working or not. So basically, you place a silicon in a motherboard, right? And then you check all the other domains which is connected to that particular silicon, right? So consider like USB is one domain, okay? Type C and Thunderbolt is one domain. Display is one domain. Audio is another domain. Power and performance is another domain. Sensors, another domain. So um, your engineers would be sitting there and then testing all of these domains separately or validating all of these domains separately to check whether it is qualified or no. Okay. And then along with the OS above all of these. Okay. So consider like if you're trying to test um, Type C features or consider Thunderbolt feature you're trying to test, right? So you may have to create an entire test plan, okay, where you have multiple use cases, and under that use cases you will have multiple test cases. So you may have to go run all of them and make sure that everything, whichever features are enabled so far, so you may have to test it and make sure that everything is working fine. Okay, consider like you are connecting a Type C display to the port in Type C interface. Then you check, you open your first thing you plug in, then you open your device manager. Since your Type C is part of your 3.1 extensible host controller, which is again sitting on your CPU. So you may have to check under system devices in under if it is USB 4, then you may have to check on USB 4 controller. You check whether the display is coming up along with other display adapters in the device manager. So you check all of these, whether enumeration is coming up or no. So this is one test case. Okay, your display is coming up or no, what resolution it has, or whether it is working in the expected refresh rate or no. So all of these things you check in the post silicon validation. Okay, so then this is on the functional validation side. Okay, so you check all the features of that particular system. So this is more like a feature validation. So you in each domains you check all of those test cases which is necessary for that domain. Okay, and you may check all the SX cycles. SX meaning, so S0 is the up and running state where your system is completely active. S3 is sleep state. S4 is more like a hibernate, S5 is shut down. So you create test cases in such a way that reboot is another scenario. So you create test cases in such a way that it should work in the sleep or idle scenarios or like S4. All of those things you check in the feature validation. So then you have your stress testing. So stress is more like you try to stress your hardware by using the multiple cycles of SX. Okay, as I mentioned, could be S3 sleep, it could be S4 which is shut down, it could be S5 or S4 which is hibernate and S5 which is shut down, then reboot. So you try to run long run in systems to understand how it is behaving. So you will have all the automated tools to run that particular um, reference ports. Okay, and you might run like 4,000 cycles or 5,000 cycles or how much ever according to your test case you run in multiple systems. This happens not only on one system. You may have multiple racks of systems which are lying with a particular stack running. Stack as in like you will have softwares, firmwares, consider like you have a work week, this particular stack is released, this particular firmwares, drivers, all of those are released. You try to flash that particular firmwares and software on your motherboard. You try to run these cycles for like longer hours, maybe 1 day, 2 day, how much ever cycles you run. Based on that, it will run for days and then on multiple systems, maybe like in racks. They will run it and then figure out if you have any failures. Sometimes you connect like external devices also. That's what you call input output traffic, right? So when you try to connect certain devices to the system, so at that time how it is behaving, right? Consider like you're connecting any type C devices or like you're trying to connect some displays. So how your system is behaving when you are running the long duration test, so how the CPU is behaving at that point in time. So when you run these cycles, you try to run certain tools also to understand whether at what point it is failing, or is it like a workload related issue, or is it something on the particular domain. For example, your display is causing some problem, or so such kind of tools also will run along with it so that we can understand why this failure is happening. Okay, and so when you find some issue, you may have to reconfirm it again, because since it is a long run scenario, so it can be extremely sporadic also. Sometimes like external environmental factors also can cause a problem in this case, so you have to make sure by retesting it again. So yeah, this is on the stress testing. Then you have your power validation. So power and performance both. So in power and performance, you mostly check like how the power transition is happening. So ideally, when you have a system up and running, you will have certain CPU states which ideally it should be running. So when it goes to low power mode, when you keep the system in idle, then it should be in particular CPU state, which is called as C states. Okay, and at the same time, when it goes to your low power mode, like consider like in sleep it should go to this particular CPU state, or in hibernate it should be this. Okay, all of those things are already defined, and you may have to check whether your CPU states are as per defined as per your definition, whether it is in that particular state or no. You may have to check. Along with that, when you connect some devices, again, like devices has its own states as well. So when you connect a USB, you will have different states for that also, like USB U0 or USB suspend. All of those things also will be there. Or like consider like if you're connecting any PCI related devices, you will have like L0, L1 or L1.2. So all of those states will be there. So that can also be a cause to block your residency. So you may have to check if such kind of issue comes up. You may have to check your device is also going low whenever your system is in idle state, or when the system is going for sleep, whether your device is also going in the low power mode, to understand whether the system is behaving the way you want. And then you check on the voltage rails. So whenever the system is going on the low power state, any rails are active or no. If some rails are active, then it will block your system to go to the low power mode. So that you might check. Okay. And then active and turbo. Active meaning like up and running state. Turbo is like a performance, higher performance, like your system is running in very high performance. Okay. And at that point in time, how your system is behaving. So when the performance go high, there is a possibility, I mean, it's not a possibility, your system will get heated, right? And then your fan, you might have heard like your fan start running. So when the system is going up, then how much is your thermal numbers are going. Okay. And then there will be a cutoff number also for a CPU. Okay. So if your thermal numbers are going in that particular reaching that particular limit, then it should throttle, basically it should cut off. Okay. And then it should come down to the normal state. Okay. So that throttling behavior is happening or no. If that is not happening, then your SOC will burn. So such tests you will do in the power. And performance validation, same. So in performance validation, what you do generally, like um, you try to use some benchmarking tools to engage your cores. Okay. So how much of a cores you have, you try to utilize maximum of that cores to understand how it impacts your system. Okay. And there will always be numbers where you can refer. So they, in that particular silicon, how, what would be the target of that particular platform, or like what would be the power numbers for that particular platform. So when you test it, you should be able to meet those numbers. Okay. With the help of some tools, you would have heard, I'm not sure, Cinebench or 3D benchmarking tools. So all of those things we use to run or to engage your cores and check how your system is behaving. Same goes with memory. So you will try to engage your memory, then what would be the cache efficiency. So all of those things you test. Then PCI throughput, USB, boot time. So boot time as in like how much time it is taking to boot to OS. Okay. When you connect some device, then how the boot time is. Okay. And then whether it is, there will be defined um, boot time for a particular platform. So whether it is crossing that particular boot time or no. Okay. In the pre-OS phase as in BIOS. So BIOS phase, how much it is taking time from BIOS to OS, how long it is taking. Okay. And when it comes to USB speed, you have like USB tree view. So there you connect your USB device, then you try to, then there's one more tool, Crystal Dismark. Yeah. So you connect your USB, then you try to transfer some data. So how the speed is, or basically when you connect a USB, then consider like it, the speed of that particular USB is 10 gig. So ideally in the USB tree view, you should be able to see those values. Okay. So those checks. PCI throughput. So PCI based on which device you're connecting. Like consider like if you're connecting a Thunderbolt device, for Thunderbolt underlying protocol is PCI. It works through PCI. So consider like if you're connecting a Thunderbolt device, then the capability of Thunderbolt is like comparatively high than Type C. So consider like 40 gig for Thunderbolt 4, 40 gig would be the capability. So you check with the specific tools. So you check whether it is able to match that throughput or no. So those things you do it in the performance validation. Then yeah, so regression. So in regression, before this, okay, so whenever you find a bug, so consider like you are trying to connect a storage, and then to your type C port or a USB port, you go to your device manager, you check for the enumeration, right? And then consider like you are seeing an issue that your device manager, the enumeration is not happening. Okay, so you capture the relevant logs for it, but before that you may have to look at other scenarios also, like yeah, okay, in which scenario, in the S0 state, meaning up and running state, the enumeration is having problem, or the issue happens only in corner cases. Corner cases, when I say, like, um consider like you're putting your system into, you plugged in your device, then you putting your system into sleep, or maybe hibernation, and then you wake your system, then only you are seeing the problem. So you identify all of those things first, and then you capture the relevant logs, and then you file a bug. Okay, so mostly Jira, all of those things they use. And there are certain internal tool, internal softwares also they use to file bugs. So basically, you try to file a bug in the tool, okay, with proper title, okay, and then you may have to write how you are reproducing the issue. So basically, steps to repro. Okay, so how you connect your device, then you go to your device manager, you checked, then you are not able to see the enumeration. So such how you have duplicated that particular bug, same way you try to write it down. Then what was the actual result you are observing, what is the expected result, right? And then you try to write all the configuration details of that particular motherboard. So basically, with silicon stepping you have used. When I say silicon stepping meaning like just like drivers, you will know like there will be driver versions for all the drivers which we use, right? For every domain you will have driver version. So just like that, even for silicons also there will be stepping. So stepping is more like uh, A0, A1, so like that the names will be. So like in A0, like you will have certain fix for that particular platform. Then next time in A1, in A0 you might have figured some issue. Then the next stepping you might get a fix for that. So basically you may have to write all of those details, like which silicon stepping you are using in that particular platform. Then if your domain is considered like you're facing a USB issue, right, or a type C issue, so you may need to write down all the configuration details which is relevant for that particular domain. Okay, what is the if you're something around display you're facing, you're not able to see the display coming up, so what would be the graphics driver version? Or if you're finding an issue around BIOS, then what was the BIOS version to find that? So all of those configuration details you may have to add. Along with that, you have to add your logs as well. So for consider like you're facing a USB enumeration issue, so you may have to attach your protocol analyzer logs. Okay, so there you will see what are the transactions happening whenever you connect your USB device. So whichever logs are relevant, you attach it and you file the bug. So next thing would be the triage part, right? So in the triage part, you may have to figure out like whether if it is your display, then you connect one particular display and you are seeing this enumeration problem. So consider like you may have to test with a different monitor as well to make sure that it happens with all the monitors or only with that specific monitor. So you check all the possible triage scenarios in this case after filing a bug, and then you put all of those details as well. And then it eventually it goes to the debug. So in the debug part, whichever logs you have attached, you may analyze that. You understand, okay, this could be the problem. So sometimes what happens is like you may need to co-debug with other domain owners, right? Other domain owners meaning like consider like it is a display issue. You connect through your Type C port, and then you are facing an issue with your display. So it can be that a Type C issue also, and it could be a monitor issue, I mean as in your display issue also, meaning graphics issue also. So you may have to include that particular domain owners as well, you may have to co-debug with them. And then another thing would be the criticality. So like consider like you have a issue where once you connect your display itself is not coming. So that is more like a major feature in that particular platform which is not working. So you consider it as a critical bug. So there will be other test cases which is adjacent to this particular. So once you enable your display, you may have to run the video and check, or you may have to put the system into sleep and then you wake and check. So you all of these adjacent or like related test cases will be blocked, right? So based on that, you decide on the priority and criticality of that particular bug. So all of those things you decide, you analyze your logs, you code debug with your, if needed, you code debug with the other domain owners or individual. If it is on that particular domain itself, you may have to debug it by yourself, or like you code debug with other teams. Sometimes what happens is like you're nearing some milestones. So this is a critical bug. You may have to code debug. So you may have to run task forces or, in another word, meetings with other teams, right? To make sure that uh, you're getting a closure for that particular bug. Okay. And then you debug, and then eventually you found out the root cause of it, and then you bring in a fix. So the validation team and the development team will be different. So you may have to promote that particular bug to the respective uh, developers. Okay, for each domain there will be different developers sitting, so they will try to fix whatever in the codes or in the firmware, or maybe in the hardware level also. Sometimes you might end up facing some hardware bugs as well. So you fix all of that and you get the fix, and then you revalidate it. You validate whether that particular, you either install or like flash the firmware, or you get a new hardware, or any which ways you try to retest your platform, and then make sure that particular feature is working, and you close the bug. Okay. So but when it comes to regression, so what happens is like you observe an issue in this particular stack, right? Stack as in it will have like your OS or other firmwares or like the hardware, all the things included. So in this particular stack, you're observing a issue. Okay. So you know that with this particular driver, it is causing the problem. Consider like you have a graphics driver. So you have problem with your display, and in this particular driver, you are seeing this problem, but you go back to the n-1 stack. Okay, the previous stack which you received. So in that, you're not facing the problem. So that is considered more like a regression. So that regression testing also happens. Okay. And even for these validation also, there are milestones which we may have to achieve. Okay. So initial phase, like different names they will have. So eventually it will reach to the customer. So there will be alpha, beta, all of those phases it also has. And then you might get all of those milestone and it should pass, and then it goes to the next milestone. So regression testing is like more like you test it in the current platform, current stack. You're facing the problem. You went back to your previous stack. It is working fine. That particular driver you have changed, entire stack you have, and you change only that particular driver, and then things are working fine. Then you promote it to your respective developers, get a fix, validate it, and confirm that it is working fine. So yeah, that is on the regression side. Now, after all of these are all part of your post-silicon validation. Okay. Then once you finish your post-silicon validation, then you have the production. So in production, what happens is like you once you finish all of this validation, you give for the mass production. Basically, you will produce the silicons, then you ship it to your customers, and then you start receiving the revenue. Okay. Then what happens after the production? So this is also like a lengthy process where you send it to your customers. Okay. So customer may have to build a platform, right? With the original manufacturer, like you have your silicon manufacturer, you are the silicon manufacturer, you sold it to, you sell it to your customer. So they have their own requirement, as in not in terms of the silicon, but maybe they may have to change the interface of that particular. So consider like a silicon is capable of having 4 Thunderbolt ports on that platform. Okay, but customer would need only 2, maybe because of their cost. Okay, if you may have to provide 4, then the cost will be higher, right? So they would need only 2, or it could be a form factor problem. So it will have a smaller form factor. So you would be having space to give only 2 ports. Okay, so customer, what they will do, they will create a system based on their requirement. Okay, so they will do certain modifications at their end. Okay, and there are modifications which can be done and which shouldn't be doing. Okay, so that guidance is provided by the manufacturer. Okay, so there will be documents, there will be guidance to the customer, there will be numbers which they shouldn't be crossing, or all of those details and documents would be shared to the customer. Okay, and then sometimes like they might not need a feature of a USB at all, right? So they may have to block that. Okay, whether there is any way whether they can block it or no, whether it is advisable to block or no. So sometimes they say that we need only a display through the type C port, they do not need USB at all in that port, then that should be disabled. So such request, whether we can accommodate or no, so those things would be decided. So you provide your documents to the customer, then they checked it, then they will start building their own platforms. Okay, so at the start they will ask, like they will have queries around like all of those, and then eventually they will create a schematic around um, mm, the details which you have shared. Schematic as in like it's more like diagrams of the particular platform. Okay, even for that also, domain wise we'll be having people sitting to review the schematic which they have provided. Okay, so based on your domain you review all the schematic, right? And then make sure that the numbers are matching, the what would be the resistor value, whether they have put it properly or not, whether they have built something which it is not advisable. Okay, so those things you check in this particular review, and then give them the feedback. Whatever changes that needs to be done, this is non-agreeable. Okay, sometimes they do go ahead with the non-agreeable things also, but if such issues comes in the later point in time, then code debug would be impossible. Okay, with the customer. So we give all the guidance, then they do the changes based on that, and then out of that schematic they will build a layout. Okay, layout is more like the actual, like you would have seen motherboards, right? So layout is more like your motherboard, right? How the motherboard should be, it would be the same. Your layout would be as it is. So wherever your placement of the ICs on the board, same thing, it will reflect on your layout. Okay, so the routing, the the placement, everything which is as is your motherboard. Okay, so then you may have to review that layout, right? Whether they have done the proper, you will have the documents to refer, whether they have followed that document or no. You may have to review where they have placed the IC, what would be the trace length, where is the wire, whether they did it properly or not, the ground clearance is proper or not. So all of those things you check based on again your domain, and then you give the feedback to the customer. And then they start building their own product. Okay, with the silicon which we provided. So once they build it, then their, so till now before the customer, the validation and everything was happening in this side of the organization, right, where the silicon is built. So now the entire process in the post silicon, from the power on to post silicon validation, all of those things will happen on their labs. Okay, so the validation phase will start. So in the validation phase, basic electrical check, all of those things they will do during the power on, and then later power on phase, and then the functional validation will happen. So they will check the features whichever they have incorporated. They validate each and everything, just like how this side of the organization had happened, and then eventually they find issues in that also. So sometimes you may again have to go debug with customer to fix. Okay, so it is not necessary that it could be a silicon related problem also. So sometimes few of the drivers would be provided with the other from the other organization, right? Like for example, Intel provides graphics drivers. Okay, Intel build graphics drivers, and for example, Thunderbolt related, right? Thunderbolt related, now USB, it will run in USB 4, which is an open source, but you have like retimer firmware, which is in the path. Retimer firmware is provided by Intel. So if you find certain issues around that, you may have to debug with customer. So basically, customer will file a bug uh, to the other organization, and then uh, the same process, like you may have to get enough information from the customer. You may get the so from the customer side, it is not the reference board or the motherboard like systems. It will be mostly finished products. Okay, so the form factor will be smaller. So earlier what we had is like a bigger motherboard size, like a desktop motherboard, maybe you have seen. So sometimes bigger than that motherboard you will have. So why do we have that? Because the all the headers would be exposed. When I say headers, like you may have to probe certain things to get the logs whenever you whenever you see an issue, right? So all of those headers would be exposed on the motherboard. But at the same time, from the customer side, you may get a very smaller form factor hardware, right? Like inside your laptop, the form factor is actually very small, right? The size is very small. So that kind of, sometimes you get only the bare hardware, but sometimes you get the laptop itself. So it's pretty hard to probe or to play around with such systems. But yeah, so that's how you get the system and try to do the validation. Basically, you don't entirely validate it as a just like how we do the actual post silicon validation. So case by case scenario, you try to test whether that particular feature is working, whether it is actually um what do you say, actually consider, like if it is a retimer related problem, whether it is actually a retimer issue or no. So those things, relevant logs you capture, sometimes you rely on a customer to get the logs. So we do have a dependency on customer here, because as I said, all the debug headers won't be exposed in the customer side systems, right? So you may have sometimes rely on the customer as well. So you get all the logs, then you analyze it, understand whether it is actually a problem with your component or no. If it is not, then it will get rejected as a third party problem. Or like if it is the retimer issue, or like which is relevant to your organization, you take it up, you get a fix, you validate it, you give that to your customer, and make sure it is, I mean, get their feedback also and close the bug. Sometimes what happens is like you get an issue. So when it comes to type C, you have like many other things also in the part. So uh, retimer is provided by the original manufacturer, but at the same time you have PD. So that is a third party component. So you would not be able to debug it at your end. So in such cases, you reject it to the customer itself, so that they can take it up with the respective third party vendors. So yeah, so that is how the validation happens, and um, then yeah, so till I think end of their shipment, right? So they call it, I think, ship support, right? So till the end of their cycle also, based on the engagement with customer. So based on the engagement with customer till the end of their project, uh, we may have to provide the support. Okay, and then even after that also, sometimes what happens is like you might end up facing some field issues as well. So sometimes, and that would be very critical because the your device is already at the end customer. Okay, and they are facing that problem. Okay, and sometimes they face such issues, and it can be very burning issue. Okay, so that you might have to address even that also. So very rare you do get issues, but yeah, it will be very high or critical issues, and then even that also you may have to debug at times. So that we call as field issues. You can call it as a field issue. So you might end up facing even that also after once you deploy these systems to the end customer. Okay, and then after that, like what happens? Like the next generation platform will come, then the same engagement with whichever I mentioned, the same engagement with happens with the customer. So yeah, and we have one more topic. Yeah. So another thing, this is more like what are the tools majorly we use, like common tools we use in the post silicon validation. So. Whenever you have a what do you say, whenever you have a power related issues, like right, certain signals are not behaving as expected, like some, whenever sleep, you're coming out of sleep, this particular wake is not happening, or whenever boot is happening, so this particular signal is not going high. So in such cases you can use oscilloscope. Okay, you can probe and check how the signal is behaving. Okay, and then you have your multimeter. Multimeter is like, I think everyone will know. So just to check the power measurements. Okay, what would be the voltage, what would be the current, all of those things you check it. Okay, you can just directly probe and get it. Okay, then you have your total phase analyzers. So total phase is more or less, you can use it like if you have some PD related problem. Okay, so you can connect total phase and get the details. Okay, Lacroix protocol analyzers. So Lacroix is consider like you have a USB enumeration issue. Okay, anything around USB in the protocol layer you can capture with the help of Lacroix. Okay, so you connect. So basically, how it will connect, like you keep um, your Lacroix is more like a middleman. So you connect your device to the Lacroix, then from the Lacroix you connect it to your platform. You sniff whatever protocol transaction is happening in the middle, and you analyze it and check. So this is this is on the USB side you use. Okay. So USB protocol analyzer is another thing. So it's more or less same. Teledyne Lacroix is like the brand name. So yeah, it is more or less same. Okay, and even Type C related analyzer, Lacroix will have even Type C, USB 4, such analyzers also they are making. Then PD analyzer. So PD analyzer is um, like you have LSS analyzer. So LSS is again the brand. So you again, even that also same similar way you connect your Type C. Consider like you are not seeing some functionality working on the Type C side. You after S6 your device is not enumerating, whichever device you're connecting through Type C is not enumerating. So how will you connect it? So you keep the LSS analyzer in the middle. You connect your device on the other end of that analyzer. Then from this end to the your reference board. Okay, so you connect it in such a way, and then you run your tool, whichever you sniff basically the protocol, right? So you sniff the communication, right? So your tool will be running on your laptop basically. So you connect all of these things, you have your tool on your system, you run it, and then you try to do your experiment. Okay, and then you can see the transactions happening, whether it is behaving it as expected or no. So those things you can check it with the um, which one? What do you say? Elysis PD analyzer. Okay. So Thunderbolt analyzer, so there is no specific analyzer as such for Thunderbolt. Okay. So you have certain tools which is specific to Thunderbolt. Okay. So this is an Intel and Apple proprietary, basically Thunderbolt. It is more like a protocol. So there will be internal softwares which will be able to understand how that particular domain is working. Okay, whether it is achieving what it is supposed to be, what would be the speed, or whether the link is up or no. Okay, what is the whether the link is going to the low power mode when it is needed. All of those things you can check it with that particular tools. There is no specific analyzer for Thunderbolt as such, but you can use certain tools to understand all of these things. Okay. Mm. And then you have USB tree view. So USB tree view is like you connect your USB. It's a tool. You just run it on your system. You connect your device, then you see how it is connected. Like the tree view itself, it will show. Like in the under the device manager, you see it. That tree view it will show. Then what is the speed of it? Okay, all of those details, USB specific details, you will get to know from the USB tree view. If the speed is going low, okay, then you can check it in your USB tree view whether the speed is how the speed is or what is the speed. All of those details you will get it from the USB tree view. Then you have your device manager. Windows device manager is also very helpful. Like that is the first thing to check whenever you connect some device on your system, or even if you do not connect anything, like to check whether there is any yellow bang on your system, or like consider like your suddenly your Wi-Fi is not working, right? So you don't see your Wi-Fi icon itself on your system. Then you go to your device manager and check whether there is any yellow bang or no. Okay, and then like after restart it is not coming up, so you just go to your device manager and check whether it is there or not. So yeah. And BIOS debug logs. So BIOS debug logs, so these are serial logs you will capture. So consider like you are not able to boot your system. It is booting, but it is not reaching to the OS phase. Okay, so you may have to capture the BIOS log. So it is you connect your serial cable to your system, then you run the tool on your serial cable should be connected to your reference board. Then you have your laptop. You run your tool in that particular system, and then you try to boot your system. Since it is not booting to the OS, you try to do the scenario with the by starting the logging, and then you see the relevant logs in that particular tool to understand where the BIOS is stuck. Okay, and any other scenarios which is related to the BIOS, you can check with the BIOS debug logs. Then LaCroix, I think I have already mentioned. I will remove this. Um, mm, so yeah, and then you have OS event logs. So there will be OS related calls if something is missing. Then you can use OS event logs. Okay. And if something which is relevant to that, but so you capture ETL traces also. Consider like you have some problem with that particular driver. Okay. So there will be specific ETL traces you capture for that particular driver. Okay, so that event trace log. So those things, if anything related to OS, majorly ETL, you capture it. Okay, so you will have a software which you will run, and then you try to duplicate that particular scenario and keep that logs. Okay. Then logic analyzers. Logic analyzers are more like, um, consider like you have to probe something. Okay. So Sally logic analyzer is one of the example. So you you may have to probe certain things. Okay. So you in your reference board you will have headers which are exposed. Okay. Based on that you connect those the analyzer to that particular headers. Okay. Then you run your software on your system, okay, which you are using, and then you try to see how that particular signal is behaving. Okay. And that's how you will be able to understand whether it is behaving properly or no. So Sally logic analyzer, you use it on type C domain. If you have anything on the Thunderbolt, you use it. Okay. In other in any other, like if you have to probe some points, then you use a logic analyzer. Multimeter won't help all the time because like you will anyway not see the waveform with the help of multimeter. But even then, like multimeter is like you might have seen that the point is like very what do you say, you cannot probe very smaller points with the help of multimeter. So at that point also you can use logic analyzers or oscilloscope for that matter. So yeah, so that is on the logic analyzer. And then you have event viewer. So event viewer is again, so consider like you abruptly your system got shut down. Okay. Then what happened at that point in time, you are not running any other logging apart from that. If you're not running anything, the first thing you go and check is the event viewer log. So you go and check, it will give you some idea on what had happened just before that shutdown. Okay. So it will show some details on what happened prior to that shutdown, or like sudden restart had happened. You are not running any logs or anything, but you were testing something and suddenly this is happening. So you go and check what happened uh, in that particular time. And next thing is event viewer. Not event viewer, sorry, WinDBG. So WinDBG is like um, anything on the OS side if you have to debug, right? So not only OS side, like if you have like, consider like your system is hang, right, in a hang state. So you may need to understand what is happening. So you connect to NTBG and then you check whether where it is stuck or what is happening. All of those things you can check with the help of WinDBG. Mm, yeah, I can add one more thing. So one more thing is JTAG. So with the help of JTAG, what you can do, you can actually try to probe, or you can actually access the internal registers inside your CPU. So you can run with the help of your JTAG. It is more like an interface. You connect it again to your system, and another end would be on your reference board. And then you try to give certain commands, okay, and check whether what is that register value, okay, how it is behaving. Okay, from sleep, if it is coming back, then okay, this particular register is giving this particular value, which is again wrong. Okay, you cross check all of these details with the, you will have certain documents to refer, basically internal documents. So you refer to that and confirm whether it is behaving as per it should be or no. You will have specifications, you will have data sheets, you will have other internal documents, whichever thing you would need, you refer to all of that and then confirm. So yeah, I think that's all I have. Are you there, guys?
Yes.
Yeah. So